Great seeing you here again. My name is Luc de Kuster, founder of the Kuster Academy, and in this video I'm going to show you an example of the calculation of the early start, early finish, late start, late finish, slack, and identification of the critical path on an activity on node schedule starting from 1. The example we're going to take is the same example that we had before when we did the activity on the arrow calculations. But before we start, don't forget to click on the subscribe button, click on the bell button. Every time we have a new video, YouTube will inform you about it. So let's have a look at how this goes. Let's now start with the adding of the durations of the activities. Here we see activity A has a duration of 2 periods, B 3 periods, C 1 period, D 4 periods, E 3 periods, F 3 periods, and G 2 periods. Now with this new information we can create or we can calculate the start and the finish times of the different activities. And when you remember well from previous exercises and previous videos, we're going to do this in basically 3 steps or 4 steps, depending how we define it. But first step will be what we call the forward pass. We're going to calculate the early start and early finish times of all the activities from left to right. And we will find the duration of the project at the end of the diagram. The second step is we do the backward pass and we start from the finish. And we are going to calculate what we call the late start and late finish times of all the activities. Based on this, we can calculate the slack. The slack indicates the flexibility, and we can also identify the critical path. Be aware, the critical path is the path which has the longest duration over the project. So we will have to evaluate all the paths and see which of the paths is the one with the longest duration. That will be the critical path. And don't forget, we may have more than one critical path. It's not uncommon, it can happen, and in some cases it will happen. So let's start first with what we call the forward pass. And the forward pass, we have 2 formulas that we have to remember. First of all, to calculate the early finish, we have the early start plus the duration minus 1. And the early start of the follow-up activity is the early start of the previous one plus 1. Now, it's very important to make a distinction here because these formulas are valid when we start the calculations from 1. We can also do these calculations starting from 0, and then the formulas will be different and the numbers will be a little bit different too. So let's start from 1. So activity A will start at period 1 and finish at period 2. So if 1 plus 2 minus 1 is 2. B will start on period 1 and finish on period 3. And C will start on period 1 and finish on period 1. So basically starts in the morning and finishes in the evening or at the end of the day. The next thing we can do is calculate the parameters for B. So we know since the early finish of A is 2, the early start of B will be equal to 3. We can then calculate the early finish of B. 3 plus 4 minus 1 is 6. And we see for G we have 2 predecessors. And we have to take the early start, which is the highest. In this case, the early finish of 6 plus 1 gives us the highest value for the early start of G. So G starts at period 7. 7 plus 2 minus 1. It means that G will end at an early finish time of 8. Now we can do the same for the other activities. We see for E and F, we see for E 3 plus 1 and is 4, and 4 plus 3 minus 1 is 6. For F, we have 2 activities we have to consider, B and C, but we see that the early finish of B is the highest, so we will take the early finish of B to calculate the early start of F, which is 3 plus 1 is 4, which leads to the fact that the end time, early finish of F, is equal to 6. This leads to the definition that the project has a duration of 8, and based on this we can calculate the backward pass. And for the backward pass we start from the early finish time, the maximum early finish time of the project. So now we have different formulas. We have the elements. We can, of course, start going back from period 8. The latest finish for G is 8. The latest finish for E is 8. And the latest finish for F is also 8. And we have to find the formulas going back. And now we can say that the latest start, since we have the latest finish, we have to calculate the late start. So the late start of the activity is equal to the late finish of the activity minus the duration plus 1. And when we go to the predecessors, we have to take the lowest value to calculate the late finish of the activity, which is equal to the late start of the follow-up activity minus 1. So for G we find 8 minus 2 plus 1 is 7. And we continue with E. So with E we have 8 minus 3 plus 1 is 6. And for F we also find 6. Now we can calculate the late finish of D, which is 7 minus 1. And we find the late start, 6 minus 4 plus 1 is 3. And we do the same for A. For A, the late finish is late start of D minus 1, which is 2. And we find finally the late start of A equal to B1. We continue with B, so we take the lowest value of the successor. So we have 7, 6, and 6. So 6 is the lowest value. So the late finish of B is equal to 6 minus 1. And the late start is 5 minus 3 plus 1, which is equal to 3. We now do the same for C. We find the late finish of C is equal to 5, 6 minus 1. And the late start is 5 minus 1 plus 1 is equal to 5. So now we finish the backward pass of this exercise. Let's now continue with the last part. We're going to find the slack. The slack is the difference with early finish and early start, or late finish or late start. And we find that the slack for A is 0, for D is 0, for G is 0. For B we find 5 minus 3 is 2. For E we also find 2. For C we find 4. And for F gives us 8 minus 6 is 2. So now we completed everything. The only thing we still have to do is to identify the critical path. Now when we look at this, we see that the critical path is the longest path, and in this case this is the path ADG. You can calculate the duration of all the other parts at BG, BE, BF and CF. You will see that they're all less than 8. And in this case, we see that the slack of the critical path is equal to 0. Now you have to be careful. The critical path in these conditions will have a slack equal to 0, but saying that the path with slack 0 is the critical path is a wrong interpretation. The only correct definition is the critical path is the longest path to the network. So that was it for this calculation, for the exercise. And we will compare these numbers with the numbers obtained from the other example when we will start from 0 in the other video. So that was it. Thank you very much. I'm looking forward to seeing you in the next video. But before you go, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Bye bye.